Today's lesson is on multiplying a polynomial by a monomial. Here we have a monomial, 2a squared, and we're going to multiply that times this polynomial that's in the parentheses, a squared minus 3a plus 1. We're going to follow the steps above to get our answer, to get the product of these two polynomials multiplied together. So we're going to start by multiplying the numbers on the outside of the parentheses to each of the numbers on the inside of the parentheses. We're going to start with the coefficients. So I'm going to start with 2. I'm going to multiply that 2 times every coefficient inside the parentheses. Here I have a squared. A squared does not have a number that's showing, but as you recall from other things that we've done, anytime you have a variable, you always have a coefficient. If there's nothing showing, that coefficient is 1. So we're going to multiply 2 times 1, and we're going to get 2. Then we're going to multiply our 2 times our negative 3. Don't forget that negative when you multiply. That is negative 3, not 3. So 2 times negative 3 would be negative 6. And then we multiply our 2 times our 1, and we'll get 2. Notice I am spreading out my answers a little bit. And that's because I need to add my variables in the next step. Okay, in the next step it says we're going to add our exponents of the variables on the outside of the parentheses to the same variables that are in every term inside the parentheses. And what this means is that I'm going to multiply my variables together, the one on the outside to each of the ones on the inside. But as you remember from the properties of laws of exponents, that anytime you multiply something together with exponents, you just simply add those exponents together. It's important though that you make sure that you're multiplying the same variables together. In this one we only have a's, but later we'll have other examples. So here we have a squared. We're going to multiply that times a squared. A squared times a squared is going to be a to the 4th power. We know it's the 4th power because we're adding those exponents together. Then we're going to multiply a squared times a. And there's no exponent showing, but if there's no exponent showing, we always know there's going to be an exponent of 1. So a squared times a to the 1st is going to be a cubed, or a to the 3rd power, because 2 plus 1 is 3. On the next term, we're going to multiply a, and there is no variable there, so we're just simply going to write a squared in there. It's the same as if we were multiplying the a squared times a to the 0 power. If you recall from exponents that anytime you have a variable or any number to the 0 power, that's always 1. So you're multiplying your a squared times 1. Then I'm going to rewrite these with the proper operation symbols and make sure that I put this in standard form. And when I put this in standard form, I need to put the terms in order from the highest exponent to the lowest. And that's with the first variable. So I'm going to look here, and here I have the variable a to the 4th power. My exponent is 4. And then I have cubed and squared. So that is from greatest to least. So I'm going to rewrite that with my operation symbols. 2a to the 4th minus 6a cubed plus, the 2 is positive here, so that's plus 2a squared. So when I multiply 2a squared times a squared minus 3a to the 1st plus 1, the answer that I'm going to get is 2a to the 4th minus 6a cubed plus 2a squared. Now we're going to do a few examples. The first problem that's shown is the problem we just did in the examples with the steps. So we're going to skip to the second example. If you look here, we have negative x cubed, which is our monomial, and we're going to multiply that times the trinomial 2x squared times y, 2x squared y, minus x to the 4th y squared minus 8y. Now in this problem, we have two different kinds of variables. We have the x, and then we have y. On the outside of the parentheses, we only have an x, so we can only multiply that x times the other x's. We're not really multiplying those times the y's. So the x's are the only thing that will be changing. To start off with, though, we want to multiply our coefficients. And here in front of the x, there is no coefficient, so we need to make sure we add that 1 so that we recognize that the coefficient is -1. And the very first thing we want to distribute to each of the numbers inside the parentheses is the -1. So we're going to start by taking our -1. We're going to multiply it times 2, and -1 times 2 is -2. Then we're going to multiply our -1, and here we have another coefficient that's not showing, so we need to add that 1 in there. So we have -1 times -1, and that's going to be +1. Again, I'm leaving space for my variables. Then I'm going to take my -1, and I'm going to multiply it times my -8. Remember that negative, that minus sign is telling you that the 8 is negative. So -1 times -8 is +8. Now here's where you need to be very careful that you only multiply your x's together and you don't change anything in your y's. Your y's should remain the same throughout your answer. So here I have x cubed. I'm going to multiply my x cubed just times my x squared. And when I do that, I just add my exponents together. So I will have x to the 5th power. Then I'm going to multiply my x cubed times my x to the 4th. Again, I'm going to add my exponents together, and I will get x to the 7th power. And on this next problem, the very last one, I don't have an x. So again, that's like having x to the 0 power or 1. So x cubed times x to the 0 power is just x cubed. Or x cubed times 1 is x cubed. All right. Now I don't have any y's to distribute in my equation, or in my expression, because there are no y's outside the parentheses. So what I need to do then is I just take these y's that are inside the parentheses and rewrite them into my answer, because that would be like distributing 1 times y, or 1 times y squared, and then the y would be here. The very last thing I want to do is I want to write my answer in standard form based on the first variable and that exponent of the first variable. And I want to add in my operation symbols by whether my numbers are positive or negative. Here, our first variable is x on all of these. And if we look at this x to the 5th, and then we have x to the 7th. X to the 7th is greater than x to the 5th. So that needs to be my very first term in my answer. So x to the 7th y squared. I don't need to carry over the 1 if I don't want to. Then to the 5th will be next, so that'll be minus, because that's a -2, 2x to the 5th, y. And then I'm going to add this 8x cubed y. So if I were to look at this problem again, -x cubed times 2x squared y minus x to the 4th y squared minus 8y, my answer would be x to the 7th y squared minus 2x to the 5th y plus 8x cubed y. All right, my next example has a fraction in it, and it looks like it's going to be a little more difficult, but it's not. You might be tempted at first to clear this fraction, but you cannot clear fractions on an expression, only on an equation where you can multiply both sides by a particular number. So here you need to just work out the problem with the fraction. We're going to do this just like we did the other problem. So we're going to distribute our coefficient first. So here we have 1/4. We're going to distribute it to 8. Now 1/4 times 8 will be 2. If you need to multiply that out, you can by just saying 1/4 times 8 over 1. And when you multiply those together, you're going to get 8 over 4, which would reduce to 2. So 1/4 times 8 is 2. Then I can distribute my 1/4 times my 12. 1/4 of 12 is 3, so that will be 3. and I'm going to distribute my 1/4 times my 4, and 1/4 of 4 is 1. So now I just do the variables just like I did on the other problems. I have x cubed, and I'm going to multiply that times x squared. I add my variables together, so I will have x to the 5th power. Then I have x cubed times x cubed times x. The x has a power of 1, so we're going to have x to the 4th power. And then x cubed times 4, which there is no variable that is showing in that problem, so then that would be just like multiplying it times 1, and you would have x cubed. My 4 here looks like it's not a exponent, so let me change that real quick, make it look more like an exponent. Okay, so now I'm going to check to see if it's in standard form. I do have the exponent 5, then 4, then 3. So it is in standard form. I'm going to rewrite that though with the operations. So it's going to be 2x to the 5th plus 3x to the 4th. And this should be a -1. So it'll be minus 1x cubed. And the reason this is negative, we'll go back real quick. 1/4 times -4 is -1, not 1. So when I multiply this problem together, the answer that I get is 2x to the 5th, 3x to the 4th, minus 1x cubed. All right, on our last problem, it's a little more complex. We have a little bit higher numbers, and we have the variables x and y. So let's give this a try. We're going to start by multiplying our coefficients. So we'll have 6 times 3, and we'll get 18. And then 6 times 2, and we'll have 12. And 6 times -8 is 48. The next thing we're going to multiply is our x's. So I have x squared times x squared plus x to the 1st power is going to be x cubed. And then x squared times x, again we have x cubed. And then we have x squared, and there's no x in that equation, so that's just like multiplying it times 1, so that will be x squared. Our next variable is y, so we're going to distribute the y. Start with y, and in this equation right here, in this expression, there is no y, so we have y times 3x, and so that's like there's a 1 there, so we'll just plug in the y by itself, and then a y times y will be y squared, and again, y times y will be y squared. Now, when I look at this, I need to check to see if it is in standard form. And when I first look at it, I'm going to find that in my first variable, x cubed is here, but I also have an x cubed here. This is x squared, so that will be the last one. But I need to decide between the 18x cubed y and the 12x cubed y squared, which will come first. If you have your leading variable and you have a match to that, in other words, x cubed and then x cubed, then you're going to go to your very next variable to see what number comes first. Here I only have y, so that would be like y to the 1st, but here I have y squared. So 12x cubed y squared will have to be my first term when I'm writing it in standard form. So 12x cubed y squared, and we're going to have a plus because 18 is positive, 18 plus 18x cubed y, and then plus, actually this should be -48, so minus 48x squared y squared. Be very careful with these negatives that you don't forget to change that to a negative. So here's my answer. 12x cubed y squared plus 18x cubed y minus 48x squared y squared. Now what we're going to do is we're going to use what we learned about multiplying polynomials together, and we're going to use that to find the area of this triangle below. If you look here below, you'll see that you're going to use the formula area equals base 1/2 base times height. And here it says that our base is going to be 4x squared plus 2x minus 6. And our height of the triangle, which the height of any triangle is from the vertex perpendicular to the base, so that is 7x squared. The very first thing we need to do is plug both of these into the formula. So we know that area is equal to 1/2 the base, which is 7x squared, times, I'm sorry, the base, which is 4x. Let me start over here. I'm going to use a different color marker too because it's not writing dark enough for me. So let's start again. Area is equal to 1/2 the base, which is 4x squared plus 2x minus 6. And then we're going to take that and we're going to multiply that times the height, which is 7x squared. In order to get the area of this triangle, we're going to have to multiply all three pieces together. But as you remember with multiplying numbers together, you're not going to distribute this 1/2 to both polynomials. You're only going to do it to the first one. So I'm going to start off by distributing my 1/2 to 4x squared. So just like the others, when I multiply 1/2 times 4x squared, I'm just going to multiply it times the coefficient. So 1/2 of 4 is 2. I don't have a variable here on the outside of the parentheses, so it's going to remain x squared. Then I'm going to multiply the 1/2 times the 2x, and again, 1/2 of 2 is going to be 1. I do not have a variable on the outside of the parentheses, so I can just bring down my x because that's like 1 times x. And then 1/2 times 6, which will be -6, which will be -3. So when I multiply 1/2 times 4x squared plus 2x minus 6, I get 2x squared plus 1x minus 3. I'm not done though, because I still need to take this polynomial and multiply it times the monomial 7x squared. Now if you look here, it's written backwards compared to everything else we've had because we have the monomial in the back, and we're still going to do the same thing in that we're going to distribute it to each piece. But if you don't like that, you don't like having it as the second expression, then we can rewrite this so that it looks like the other one. So we can have 7x squared times 2x squared plus, I'm just going to put it x because we know that x is the same as 1x minus 3. Now we can move these around because as you remember from your properties, that the commutative property of multiplication says that you can do things in any order. You can move your numbers around. So we're going to multiply these two, the monomial to the polynomial, and we're going to start with our coefficient of 7. We're going to distribute that to each of the pieces inside the parentheses. So 7 times 2 will be 14. 7 times 1, because there's a 1 there, will be 7. And 7 times -3 is -21. Then we take our x squared. I'm going to draw this underneath this time. X squared times x squared. If I add my two exponents together, I get x to the 4th. I'm going to put that plus there now. And then x squared times x. That's x squared plus, or the 2 plus the 1, which is 3, so that'll be x cubed. And then when I multiply the x squared over here, there's nothing there, so that's like multiplying it times 1. So that will be x squared. I check to see if my answer is in standard form, and I have 4, 3, 2 as my exponent, so it is in standard form. So when I multiply, or when I'm finding the area of this triangle, using the formula 1/2 base times height, I have 14 x to the fourth plus 7 x cubed minus 21 x squared. And that will be the area of my triangle. In order to do this, we had to use the same process as we did with all of the others, where we just distribute everything on the outside of the parentheses to the inside of the parentheses, though we actually had 3 things to multiply this time instead of 2. The last thing that we're going to be doing today is we're going to use the same ideas that we've been working with of multiplying the polynomials together, and we're going to throw this in as functions. We're going to start using these with functions. So in this first problem, if I said that f of x is equal to 3x, and I said g of x is equal to 3x squared minus 6x, and I needed to find f of x times g of x, I'm going to take both of these, I'm just going to rewrite them and multiply them together using the same process we did before. So I know that my f of x is 3x, and to show that I'm multiplying it, I'm just going to put it in the parentheses. And then I'm going to have my g of x, which is 3x squared minus 6x. I start by distributing my coefficient. 3 times 3 is 9. 3 times negative 6 is negative 18. Then I can distribute my variables. X times x squared. I add those exponents together and I get x cubed. And then x times x is x squared. I look to see if it's in standard form, and it is. So f of x times g of x is just 9x cubed minus 18x squared. This is the exact same process as before. They're just called something different. You're just given the functions, and then you need to multiply the functions together exactly like you did on the other problems. Now, on the last problem we're going to be doing today, we're going to be using division. And so we have to go back and remember some of our ideas that we used when we did fractions, because it's going to be set up just like a fraction. Here I need to take g of x, and I'm going to divide it by f of x. So to start off with, I'm going to plug in the functions, or what the functions are equal to, and create a new fraction. So my g of x is going to be 3x squared minus 6x. And my f of x is 3x. Now, as you recall with fractions, if I have an expression over a number or a monomial, I can break that fraction up into 2 parts. So 3x squared minus 6x over 3x is the same as saying 3x squared over 3x minus 6x over 3x. These two problems are exactly the same. They're equal to each other. So from here, I'm going to simplify both of my fractions so that I can subtract them. So I can first start with my 3 over 3, and that's going to cancel out to 1. And then I have x squared divided by x, and as you recall from the unit with exponents, that the x on the bottom, the denominator, has an exponent of 1, so that's the same as saying 2 minus 1. So x squared divided by x to the first power is going to equal x, because 2 minus the 1 is equal to x to the first power. So this fraction here will cancel out to have x to the first power. Okay. Then we're going to start with this problem. We're going to finish with this problem. We're going to start with the coefficients. 6 divided by 3 will be 2, because 3 goes into 6 2 times, and of course into 3 once. My x's can cancel out here, so I'm left with the number 2. So if I was to divide g of x by f of x, the answer I'm going to get is x minus 2. The key to these type of problems is that you break up the problem so you can reduce each piece individually. And that is it for the lesson on multiplying monomials and polynomials together. The important things that you need to remember is that you need to watch your negative signs so that you don't make things that are positive that should be negative. And then basically you just distribute the things on the outside of the parentheses to everything on the inside of the parentheses.